everybody, so welcome back. I'm Elisa. We're talking about the heart, and this time we're going to talk about cardiac muscle histology and what those cells look like and what some of the names of the parts of the cells and the tissue are. All right, so cardiomyocytes. Cardio means heart, myo means muscle, and then cytes means cells, right? So they're striated, which striated means they're stripy. Okay, they're short, they're thick, whatever, which we'll talk about that as well. Um, so the thing is like when the heart has to always beat. Like the heart is not like, your leg muscles after you've been running. You get to rest every other muscle in your body except for like your cardiac muscle. And so in the event that you have like damaged cardiac muscle because of lack of blood supply, mostly just that, like whatever other reasons, cardiac muscle can't really repair itself very well. And so what has to happen is it has to just lay down fibrous material, so it's like collagen and all that good stuff, which is basically the duct tape of the body. So some of the things that are here, let me just kind of put this in here. All right, so here are some cardiac muscles. So cardiac muscles have a few things. You can see they have stripes. So like it's not these big ones that we're talking about, although those are important, okay? So when we're talking about them being striated, we're actually talking about like these teeny tiny ones right here. So it's little guys, right? Those are the striations we're talking about, because they represent the sarcomere, which is the functional contractile unit of muscle. And so what you see when you see these big sort of stripy things are actually intercalated discs. And what's kind of interesting about like muscle cells is this is the border between like this muscle cell and like this muscle cell, like over here. I don't know where that nucleus is, but so that's what all of this is referring to. Okay. So muscles kind of have this like strange phenoform in that way. They branch out. And that is what allows them to make like that conical shape of the heart, like in a 3D kind of context. Those are blood vessels. Those are the great vessels. Now it looks like, I don't know, a dude. Sorry, that was a terrible drawing. Try to refrain from drawing too terribly. Okay, and so that's what that's referring to. So striations, intercalated discs. So intercalated, actually comes from calendar, which is a bit of a misnomer. It's like they're intertwined, and so they're just like there's just a lot of connective tissue between like this muscle cell and this muscle cell here, so they kind of stay together, if that makes sense. Right, so let's move on a little bit more. So here's the structure of cardiac muscle altogether. Here's the nucleus itself. And so this like red bit down here where it's all like kind of long. So what that is those are just huge repeating units of sarcomere. So that's like the part that's going to act like a bit of a spring, and it's going to contract and it's going to relax. In order for muscle to move and do all of that like synchronized, highly organized motion, we're going to need a lot of energy. And so mitochondria usually kind of are going to sit between those structures. And the other thing you'll find is we'll find like storage of glycogen, right? And glycogen is like the long-term energy storage molecule for carbohydrates in animals, right? Starch for plants, essentially. And so that's going to be there. Right. Good. So we'll look at this a little bit more later on, but just like for the fast and dirty, you have to think of all of these muscle cells here, like at the intercalated disc, if you will. That's what this like space is supposed to be representing. They not only attach muscles to muscles, but they also do things like help facilitate communication, right? So these are little like chemical messenger tunnels right here. The fascia adherens is just what's going to be keeping supergluing one cell to the next cell over here as well. Okay. So cardiac muscle is really oxygen dependent, which is why when someone is deprived of oxygen, it can result in their heart, in heart failure. It needs to make a ton of ATP. Like you saw all of those mitochondria, right? So it's like has to make a ton because it's moving and that's doing a lot of it. The mitochondria are actually larger in size than an average cell's mitochondria, and they technically fill up to 25% of the cell. Right. So, I think that's kind of like the mouse. Okay, right. So we'll get into the conduction system next. But for now, I think I just want to say I'm glad you were here. I'm glad you checked this out, and I hope you're having a wonderful day. Goodbye now.